Okay, let's talk about inequalities. So we're going to translate from English to math, just like in any old word problem. And it says 4 is greater than x. Now you can rewrite that like this if you want. It'd be the same thing. Most people put the variable on the left side. And it means the same thing because notice this arrow, it's pointing at the x. Well, it's still pointing at the x. So it's equivalent, okay? Let's see, and we are looking for also this part here. It says -3 is less than x. So -3 is less than x. And if we flip it around, so it's a little more traditional looking, it looks like that. And then that would be what you plug in. Okay, on this one, once again, we're writing a compound inequality, but instead of being given some stuff in English, we are given, let's make that just a little bigger. We are given some, just given the graph. Okay, well, this piece of the graph looks like it's shaded in all numbers that are less than or equal to 5, less than 5 or equal to 5. And we also have shaded in all numbers that are bigger than 7 or equal to 7. Yeah, that's how it's done. Let's do one more of those. This time we only have one shaded region, and the numbers that are shaded there are numbers between 3 and 7, but including 3. Not including 7, so I don't put the or equal sign there. So that's it. Okay, so now we're solving for x. Super cool. What more could a guy ask for? Okay, so first let's get rid of those parentheses. So I'll multiply the -5. Whoops, I don't want that. So to get rid of it. Multiply the -5 through. And then multiply the 3 through the parentheses. Okay, we can combine like terms on the left side a little bit. Those two right there. And then let's add 3x to both sides. And then we'll add 5 to both sides. Then we'll divide by -2, which flips the inequality. And we got that. And then that's all that Alex is looking for. But you could, if you wanted to, say the shaded region is that. And in interval notation, it would be -infinity to -7, parenthesis, bracket. Bracket because of that shaded in circle on the -7. All right. So we've got this to solve and this to solve separately from each other. So we're gonna, we'll just do the one on the left first. We'll add 5 to both sides. And then we'll divide by 2. This time I'm not dividing by a negative, so I don't flip the inequality sign around. Okay, now our answer is those numbers less than -5, or now let's do this one. I'll add 2 to both sides. Divide by 3. I get that. Okay, so x less than -5 looks like that. And x greater than or equal to -2 looks like that. Now, it depends, how we combine these two solution regions to get our final solution depends on whether we have an and or an or. If it were an and, we would say, oh, this solution set needs to be satisfied and this one. Well, there are no numbers that are in both, and so if it were an and, the answer would be no solution. But that's not the case. It's an or. And what an or means is you just keep everything. Okay, so for something to be in the solution set, it just needs to satisfy this or this. It doesn't have to do both. It doesn't have to do one and the other. So our solution region on the number line, you know what, let me change colors because that'll be more fun for everybody. Our solution region on the number line for this one is going to look like this. And in interval notation, it would be negative infinity to negative 5 with a parenthesis union to connect. That connects the two pieces of the solution set. Negative 2 to infinity. But this is what they're looking for on this one. Okay, let's do one more of those. This time we've got an and floating around. So first we solve the two inequalities. All right, so I'll subtract 4. And I'll divide by 3. Okay, so we've got that and the other one. Subtract 2 and divide by 3. So x greater than or equal to negative 2 looks like that. X less than or equal to 3 looks like that. And so because there's an and, our solution set is only made up of those numbers that satisfy that area and that area. In other words, only those numbers on the number line that are in both, where the two of them overlap. Well, they overlap between negative 2 and 3. So on the number line, it's going to look like that. And in interval notation, it'll have brackets because of those filled in circles. Okay, so now same thing, except they want us to do it interval notation. Well, I just showed how to do that on the last couple of problems, so I'm just gonna move on, to be honest. Okay, so how do we solve absolute value inequalities? Glad you asked. Okay, so first you have to get the absolute value statement isolated. So if we add 19 to both sides, we get that. Okay. Now, at this point, we rewrite it twice. Rewrite this the statement twice. Once, just like it is, but without the absolute value bars. And then do it again, pretty much the same way, except we're going to change the sign of the guy on the other side, on the right, and which essentially we're multiplying by -1. I'm not going into all the details. And then so that means we're going to have to flip that guy around there. Now, the only question is, do we combine them with an and or an or? With or and. Here's how we tell. Once the absolute value expression is isolated, like it is right here, that's when we determine. And we say, well, at this point, its absolute value is greater than. Okay. And greater than means we're going to do an or. If it had been a less than, we would do an and. That's how you figure it out. So we'll put an or right there. An or means, well, and means only take where they overlap, but or means keep it all. So we've got v greater than or equal to 6. And we have v less than or equal to -6. And we're going to keep all of it, whether it overlaps or not. And none of it overlaps. That'd be it. And if I write it in interval notation, it would be negative infinity to -6 with a bracket, union, bracket, 6 to infinity. So how do you remember that? Well, you can remember Gola, like a monster, I don't know. Or go back to LA, Californian. Or go Lakers. Or like in soccer, you could read it clockwise. Goal. It makes the word goal. Isn't that wonderful and special? Okay. Anyway, so that's how these are done. Again, if it had been an and, you would just look for where the two of these guys overlap, and that would be the only difference. All righty. So here's another one. This is now type 5. It's not really all that different from the last one. Okay, so let's start by getting the absolute value expression by itself. We'll add 6 to both sides. I don't know why Alex likes using the variable v so much. Whatever. Okay, so now that the absolute value is by itself, we'll rewrite the whole thing without the absolute value bars. Then we'll rewrite it again, flipping the inequality, changing the sign on the right. And what do we get? Is it and or? Turns out because we have a less than, we're going to get and. Okay. Now we solve them both. I'll add 2 to both sides and divide by 4. And then the second one, we'll add 2 to both sides and divide by 4. Okay, so we have, oh, whoops, wrote that down. It's supposed to be less than or equal, not equal. Okay, so the first one over here, we have v less than or equal to 4. And the second one is v is greater than or equal to -3. And we're looking, we have and because of the less than sign. Therefore, we want to know where the two of them overlap. Well, everything from -3 to 4 is what they have in common. That's where they overlap. So let's see, so if I do it on the number line, it looks like this. And if I do it in interval notation, it looks like that. And if I do it in inequality notation, it looks like that. So all three of these are the same thing. They're just written differently. It's kind of like saying, I want to say hello. Here's how I say it in English. Here's how I say it in Spanish. Here's how I say it in German, or something. But it all means the exact same thing.